Quad beam balance. Ileana is going to assist us with using the quad beam balance. She always has a smile on her face when she is doing science and engineering. Unlike the electronic balance, with the quad beam balance you can see where the name balance comes from. Like the electronic balance, we must first zero the balance. However, with this style of balance, it will take a bit longer. First, slide all of the sliders to their zero marks. These can be found on the far left. Once in this position, the knurled nut on the left side of the beam is loosened or tightened until the beam line on the right lines up with the line on the fixed portion of the balance. This will take a bit of back and forth until you get it just right. To adjust the beam side up, loosen the nut, turn counterclockwise. Righty-tighty, lefty-loosey. To adjust down, turn it in the opposite direction. Once the balance is zeroed, you are ready to take a measurement. Ileana is going to measure the mass of a beaker. When she places the beaker on the balance pan, it will go out of balance. Now slide the sliders back and forth until you re-establish balance. Start with the largest place value. In this case, it is the hundredths place. Move the slider until the beam goes out of balance in the opposite direction. Then move it back one slot. Do this for each subsequent beam, being careful to make sure that the beam is still lower on the left side than on the right. For the sliders where there are notches in the beam, make sure that the slider is firmly in the notch. For a proper reading, they are not to be between notches. The closest slider is the only exception to this, as it has no notches. Slide the smallest slider back and forth until you re-establish balance and the lines line up. Once you have established balance, you are ready to read the balance. Read from the largest place value to the smallest. In this case, notice that the slider indicating the hundredths place is in the zero slot, so there is a zero in the hundredths place. Next we move to the tens place. The slider is in the 90 slot, so there is a 9 in the tens place. We do the same for the ones place beam, and we see that it is in the 8 slot, so we put an 8 in the ones place for our measurement. Now for the decimal places. Zooming in, we can see that on the tenths beam, the slider is reading somewhere between 0.5 and 0.6. So we can add the 5 to the tenths place in our measurement. This is a centigram balance, so that means we have graduations to the hundredth of a gram and can make estimates to 1,000th of a gram. Fine-tuning our estimate, we see that the slider indicates a measurement between 0.52 and 0.53, so we can add the 2 to the hundredths place. Now we need to make an estimate. In our mind's eye, we divide the space between 0.52 and 0.53 into 10 equal parts and estimate the final digit. If there are 10 spaces between 100th, then each of those imaginary spaces is 1,000th. Ileana estimates that the pointer is pointing at the 9th of the 10 imaginary spaces, so the 9 can be added to the final measurement in the 1,000th place. This last digit is our doubtful digit, and is the result of the inherent uncertainty in this device. This measurement has 5 significant figures and 3 decimal places. Thanks, Ileana.